Hello all, in this video we are going to discuss about usage counts in register allocation. Instructions involving register operands are normally shorter and faster than those involving memory operands. So, efficient utilization of registers is an important task in code generation strategy. So, here the register allocation tells about what values in a program should reside in register, and register assignment tells that in which register each value should reside. Normally in a basic block, all the some variables will be stored in register, and we are going to leave the basic block. Means that is, if we are at the end of the basic block, then all the live variables must be stored in a memory. But in a global register assignment, throughout a loop, sometimes a variable must be used. So that frequently used variables must be loaded in some fixed registers throughout a loop. Okay, so in global register assignment, some fixed registers will be assigned. For example, if we are having 6 registers, some 3 registers can be assigned for loading the frequently used variables, so that the frequently used variables are loaded in that fixed registers throughout a loop, and other registers can be used for storing the other variables, normal variables. So next we will see about usage count in register allocation. So consider a variable x. So if variable x is in register, then we save 1 unit of cost for each reference to x that is not preceded by an assignment to x in the same block. That is, if the variable is in register, then we can save 1 unit of cost for each use of x in the basic block. So if the variable is using one time, means then we are going to add 1 unit of, we are going to save 1 unit of cost. And we can also save 2 units of cost if we can avoid a store of x at the end of a block. That is, if a variable is live at the end of the basic block, means then we can save 2 units because we are not going to store it into memory location. It will remain in the register only. So we can save 2 units of cost if the variable is live and in which x is assigned a value. So these are the two savings. We can save 1 unit of cost for each use of x in the basic block, and we can save 2 units of cost if we can avoid a store of x at the end of the basic block. So this is a formula for the benefit of x allocated to a register. That is, if we want to assign x to the register, if we want to allocate x to register, how much cost we can save, what is the benefit? This can be calculated with the help of this formula. So sigma blocks B in L. L means it's a loop. A loop can have any number of blocks. So for all the blocks in L, we have to calculate this formula, and a summation must be performed for all the blocks. So for each block, we need to find use of the variable x comma b plus 2 into live of x comma b, because for each use of x, we can save 1 unit of cost, and live means we can save 2 units of cost. So use of x comma b plus 2 into live of x comma b. So here use of x comma b represents number of times x is used in a given block. It may be b1, b2, anything. So use of x comma b represents number of times x is used in a block b, and it is not preceded by any assignment to x in the same block. This is the condition. And then this live of x comma b. This live of x comma b is 1 because it is multiplied by 2. So we are going to save 2 units of cost only, but 2 is multiplied here. So we are going to consider live of x comma b maybe 1 or 0. So live of x comma b is 1. That is, if x is live on exit from b and is assigned a value in b. So in these two conditions are satisfied, we are going to set live of x comma b is 1. Otherwise, live of x comma b is 0. That is, if x is dead, means live of x comma b is 0. So 2 into 0 will be 0. So this is a simple flow graph for the inner loop. This loop consists of 4 blocks B1, B2, B3, B4, and these are all the instructions in each block. And this BCDF are live on entry to the basic block 1, and these are the variables are live at the end on exit of the basic block B1. Similarly, these are the ACDE or live on entry for the basic block B2, and from the basic block B2 after B2 on exit C, D, E and F are live. Similarly, for B4 entry exit and B3 entry exit, this is for other blocks. So now we are going to calculate the usage count for all the variables used in this flow graph. So A, B, C, D, E, F. 6 variables are used in this basic block. So we are going to find the usage count. So that, what is the formula? Use of x comma b plus 2 into live of x comma b. So first we need to consider b1. This loop involves 4 blocks b1, b2, b3, b4. So summation of all should give the usage count for a. So first we need to find use of x comma b. Here x is a, the variable a. So we need to find use of a comma block b1. Use of a comma block b1 means how to find use. Number of times x is used in b and it is not preceded by an assignment to x. So here a is used. Used means it should appear in the right hand side of the equation. So here a is used one time, right? A is used one time, but it should not be preceded by an assignment to a, but here in this block b1 it is preceded by an assignment to a. Therefore 0. Plus use of a in block b1 is 0, because number of times x is used in a block b and it is not preceded by an assignment to x. So that 0 plus then 2 into live of x comma b. So we have to find live of x comma b. Live of x comma b is set to 1 if x is live on exit from b and it is assigned a value in b, right? So we have to check a is live on exit from b. A is live and it is assigned a value in b, so that we can say that live of a comma b is 1 and it should be multiplied by 2. So 2 into 1 is 2. Plus similarly we need to find a is usage count for b2. That is this formula should be calculated for b2. So we have to check use of a in b2. Use of a in b2 means how many number of times a is used in block b2. So one time it is used and it is not preceded by any assignment. So 1 plus a is live or not. Here a is not live, a is dead, so that live of a in b2, live of a in b2 is 0. So 0 plus, now we have to check b3. So in b3 a is used one time and it is not preceded by any assignment. So 1 plus a is not live on exit, so 0. Plus in b4 a is not used, so 0 plus a is not live, 0. So total value is 4. The meaning is we can save 4 units of cost. 4 units of cost can be saved by selecting a for one of the global register. So if we have 3 global registers, we can save 4 units of cost if we select a, if we store a in a register, if we assign a in a register. Okay, so similarly we can find the usage count for all the variables. So consider b. How many times b is used in basic block b1? 1, 2. Number of times 2, and it is not preceded by any assignment to b. So 2 plus b is not live on exit, so 0 plus in b2 b is not used, so 0 plus B is not live on exit, so 0, plus in B3, B is not used, so 0, plus B is live on exit and it is assigned a value, so 2. So whenever we are calculating uses, number of times the B is used in a block should be calculated, and the condition is it should not be preceded by any assignment. While calculating liveness, we have to check whether B is live on exit, and there should be an assignment to B in a basic block. Computation should be there for B. B should be assigned with some value. Okay, so here we should check it should not be preceded by any assignment. There is no assignment for B, but while calculating liveness, we have to check whether it is assigned a value or not. Okay, so in basic block B4, B is not used. Used means we have to check the right hand side only. So B is not used, so 0, and B is live on exit and assign some value, so that 2. Liveness means we have to add 2. So what is the total? 2 plus 2 plus 2. So we can save 6 units of cost if we assign B to the register. Now consider variable C. C is used one time in basic block B1 and it is not preceded by any assignment. And C is live on exit, but see that here C is live on exit, but it is not computed here. It is not assigned some value for B, so that it is 0. Then here C is not used, so 0. C is live on exit, but it is not having any assignment to C, so 0. Then C is used one time here, so 1, plus C is live on exit, but it is not assigned any value, so 0, plus C is used one time in B4 and C is live on exit, but there is no assignment for C, so 0. So the total cost is 3. 1 plus 1 plus 1, 3. Then D. D is in basic block B1. D. One time it is used. So 1. Use of D comma block B1 is 1, plus D is live on exit and it is assigned a value. So 2, plus in basic block B2, D is using one time, plus it is live on exit but it is not computed here, so 0. Here D is used in B3, D is used one time and it is live on exit but it is not computed, so 0. Here D is used one time, plus D is live on exit but it is not computed, 0. So total saving is 3 plus 1 plus 1 plus 1, so 6. Then for E, E is not used in basic block B1. It is live on exit and it is computed, so 2, plus E is not used here, so 0, plus it is live on exit but it is not computed, so 0. E is not used in block 3. E is live on exit and it is computed, so 2. E is not used here, so 0. It is live on exit and it is not, but it is not computed, so 0. So total saving is 2 plus 2, 4. Then for the final variable F, number of times it is used is 1 and it is not preceded by any assignment, so 1, plus F is live on exit but it is not computed, so 0. Here F is not used, it is live on exit and it is computed, so 2. Here F is used one time and it is not preceded by any assignment, so 1, plus F is F is live on exit but it is not computed, so 0. And here F is not used, so 0, plus F is live on exit but it is not computed, so 0. So the total saving is 4. And assume that there are 3 registers, R0, R1 and R2 are the fixed registers. That is, we can assign values to the registers. We can assign 3 variables to these registers. So here these are the savings. So if we select B, we can save 6 units of cost. Similarly, D means 6 units of cost. These are the highest cost. So we can select B and D. Next, so we can select A for register R0, B for register R1, and D for register R2. So the fixed registers R0, R1 and R2 are used for saving loading A, B and D, because if we select the variables A, B and D, we can save more units of cost. And here we can see that the E and F are also having the same number of same cost. We can save same amount of cost like A. So R0 can also be used for saving for loading E and F, E or F. So instead of A, we can also load E or F with the same benefit. So R0 can be used by A or E or F, but R1 should be used by B and R2 should be used by D. So these are all the fixed registers. If we have only 3 fixed registers, we can select 3 variables based on the usage count, savings. So other registers can be used for other computation. For example, if R3 and R4 are available, that can be used for performing other computation, like for saving for performing computation with C, E and F. So these are the usage count. Thank you.